right, we are down to the last section for the course, 7.5. And in this section, we're actually not going to be doing any proofs, all right? So we're going to take a different tack here with this predicate logic material. It's a good way to end the course because up to this point, right, you know that we've dealt with categorical syllogisms, categorical logic. We've dealt with propositional logic. And in both categorical and propositional logic, we've developed techniques to show that arguments expressed in those ways are valid or invalid, right? So we had Venn diagrams, we had the square of opposition for categorical logic. And then when it came to propositional logic, we of course had truth tables, indirect truth tables, and of course the proof technique to show that arguments were both valid and invalid, right? We can use the indirect truth tables technique, for example, to show that an argument was invalid. Well, in predicate logic here, up to this point, of course, we developed proofs so we can show that an argument expressed in predicate logic is valid, but it's not until we get to 7.5 that we actually learn about a technique that will show us how these can be proven to be invalid, all right, when we have, in fact, an invalid argument, as this is right here. And this technique is actually just the counterexample method that we developed back in 1.5. We're going to have to tweak it a little bit here because we're dealing with predicate logic, but essentially it is the same as we were working on in 1.5. And so, what we need to understand here is we have a premise and then a conclusion. And in terms of these arguments, as they'll be presented to you on the exam, I will assure you that when I'm asking you to use the counterexample method to show that these arguments are invalid, I will assure you that they are in fact invalid. Okay, so you'll know they're invalid from the outset, and your task will simply be to show that they're invalid using, again, the counterexample method. So how that goes is this. What we have here is a statement, and we need to understand what that's saying we need to translate it back into English, in other words. So this statement says, for all x, if x is an A, then x is a B, right? That's sort of the most literal way to understand the symbols here. Take anything you want. If it's an A, then it's a B. But we learned in section 7.1 that there's really a more easily understood way to express the information that we see there in that statement. Right? And it's to use the word all. All A's are B's. That's what this premise is saying here. All A's are B's, okay? And you're gonna actually need to do this as part of the counterexample method. It's a slight difference from how we did it in 1.5. You're going to actually need to write out sentences that will show that this argument is in fact invalid. And you can actually approach it in this way with this scheme. All blank are blank, and then, you know, A's and B's, okay? Likewise, we have the conclusion. The conclusion here says there exists something that's a B and there exists something that's an A. There exists something that's a B and there exists something that's an A. Or another way to put it is, B's exist and A's exist. That's essentially what this conclusion is saying. So to get good at the counterexample technique here, you're going to want to review 7.1, so you know how to take the symbols and translate them back into English, okay? So all A's are B's, and then B's exist and A's exist is what we're looking at here in this argument. Now the counterexample method said what we need to do is find substitutions that are going to make all the premises true. We just have one premise, but all the premises true and the conclusion false, okay? So we're going to need to make substitutions here for these predicates to make that happen. Now, in 1.5, what I suggested is that you start with the conclusion and make it false first and then work your way back to the premises. And that can work here, certainly, when it comes to predicate logic, though I would just encourage you to know that you have a little bit more flexibility. If you can find a good way to make the premise or premises true and then work on the conclusion being false, you can go about it that way as well. What it really takes, though, it's somewhat of an ad hoc approach, but it takes understanding what the sentence is saying and then coming up with simple substitutions, right? Remember that from 1.5. We want to use simple substitutions to plug in for these various predicates here so that we can make definitely, clearly a true premise and a clearly false conclusion. Now, in this particular problem, we will notice that the conclusion, right, is a conjunction. It's something and something else. And so we will recall, actually, back to Chapter 5, 5.2 specifically, that when you make an and statement, a conjunction false, when you want to do that, all you have to do is make one or the other of the conjuncts false. You could make them both false as well, but just making at least one of them false will ensure that you have a false conclusion in this case. And so what that means is we're going to have to think about, in this particular instance, something that doesn't exist. Something that doesn't exist will make this false, and that'll make the whole statement false, right? And so I don't know if you remember, but early on in the course, right, we had a focus a little bit on unicorns. And so we might see unicorns making a comeback here because, of course, unicorns don't exist, right? So with that in mind, we can plug in unicorns to B or A here. We want to, as well, ensure that we can plug in something for A and B here that's going to make this true. So, for example, right, we talked about this before, but if we said all unicorns are, and what can make this true, right? Well, remember, all means if there is any, right? If there is any at all, if there are any unicorns at all, they would be what? Well, they would be animals, wouldn't they? Right? We know unicorns don't exist, but if there was such a thing as a unicorn, it would be an animal. So this is a true statement. But now, when we plug those terms down into our conclusion, we get animals exist and unicorns exist. And that's clearly not the case, right? So what we do here, and what we have done in the counterexample method, is we have shown that for this argument, right, it is possible for this argument to have all true premises and yet a false conclusion. And if there's one thing you can take away from this course, I hope, it's that you will recognize that any time a deductive argument has all true premises and a false conclusion, that argument is invalid. That argument is one where we cannot accept the conclusion based on the premises given to us. All right? So this is just a quick run through here of the counterexample method. We're going to try this several times to make sure you're getting the hang of it.